For 3.3 quadratic functions and their properties, I'm going to approach this section as if you are seeing it for the first time. This is stuff that you did see in Math 2, but at the very beginning of the year. So I want to make sure that we cover it in detail, so if maybe you're not so strong with your Math 2 stuff, it hopefully will be a little bit easier for you. This beginning part of the video and we're just going to cover example 1 for this first video. It's really just what can I use to make graphing these easier? So I am not too big on vertex form. We can move stuff into vertex form, which we have here at the bottom, which the vertex, tells us where we're starting, gives us the axis of symmetry, and also gives us A, which is the width of the graph. But we don't have to move it into vertex form in order to identify those things. So throughout this section, I'm not going to be using vertex form too much. I'm going to just stick with the standard form of a quadratic, which is the ax squared plus bx plus c. What I like about this form is you are immediately given the y-intercept. So that gives you 1 point. Good place to start. You are also given the A, and we need to know that A, if I come over here, A tells you how narrow or wide your graph is. The bigger value A is, that means the faster this graph is growing. So it's going to be very narrow because it's going to grow up very fast. The smaller A is, meaning 1/2, 1/4, 1/5, 1/6, 2/3, anything between 0 and 1 will make this graph very wide, well, depending on the fraction. So we will be having to pay attention to that. Another thing to pay attention to is if x squared is positive, and that's the A that is with the x squared, or if x squared is negative. So if it's positive, it opens up. If it's negative, it is going to open down. The max and the min we will get into in the next video. We talked about that briefly in a previous section about how to tell if something is a max or a min, about the peaks and the valleys. So that part's not new, but now we're actually going to be finding that minimum value, and it may not necessarily be from a graph, which is what we did in the previous sections. And then lastly, I want to draw your attention to the axis of symmetry. This is a very, very important formula, especially since we are not going to be using vertex form. The axis of symmetry gives us the x-coordinate of the vertex. So x equals, I just like looking at it this way, x equals negative b over 2a. And b is coming from the second value in standard form, and a comes from the first value in standard form. So we use those two to help us find x. Then once we have x, we plug in to find y, and that gives us our vertex. So between the vertex, the y-intercept, and if the graph opens up or down, if it's going to be wide or narrow, we can relatively come up with a pretty easy rough sketch. So that's what we're going to do in this first example. And here, don't worry about that. Well, sorry, not H. We're really not going to worry about K. We find K a different way. That's us plugging in X to find Y. So we're going to do example 1. Let me add in the graph here. And then I'm going to make this a little bit bigger so that way we are focused on one example at a time. So let me zoom in, and we'll just do A first. I need to pause for a minute. Whoops, I need to pause for a minute, so I will be right. All right. John brought me breakfast, so I had to go get it. So we're going to focus on one example at a time, and so the directions say, if necessary, write it in the form blah. That's vertex form. It's actually never necessary to write into vertex form. We can graph this without writing into vertex form. I'm going to use the y-intercept, I'm going to use the axis of symmetry, and then I'm going to use that to find the rest of my vertex. And then I'm going to use the A to help me identify if this is going to be a narrow, a wide, or a regular width parabola. If you remember from Math 2, if I see just an x squared, that is very similar to my parent graph, which would start at 0, 0. But just to show you guys why it is 0, 0, I will go ahead and do the math. Since it's like a plus 0 here, my y-intercept is 0, 0. Since my a equals 1/4, I know that this is going to be a wide graph. And since it is positive, the x squared, the 1/4 x squared is positive, it will open up. So I just need to do the work to find my vertex. So it's x equals negative b over 2a. Well, b is 0. There is no b there. B is with the x. We have an x squared, which gives us the a, but we don't have the b. So this is negative 0 over 2 times 1/4. Well, as soon as I see that 0, I know that my x will equal 0. So to find y, I now just plug in for x. So it's 1/4 times 0 squared, so I get 0. So my vertex is 0, 0. So I'm now going to plot my vertex, so 0, 0. My vertex is also my axis of symmetry. So I have my axis of symmetry. I need to find one point on the right, which will then allow me to find the partner of that point on the opposite side of the axis of symmetry. Then that's really enough to just do a rough sketch. I'm not looking for perfection here, you guys. I just want, do you know what the vertex is, the direction of opening, the shape of the parabola, the y-intercept? That's really all I'm looking for here. So nothing super fancy. If I plug in 1 for x, this is just to give me my second point. If I plug in 1 for x, it's just 1 times 1/4, which is 1/4. So I go over 1, up 1/4. Its partner is directly on the other side of the axis of symmetry. So I can see that this is going to be a pretty wide parabola. And I'm going to make a rough sketch. Please make sure that it looks like a parabola and not a V, please, because that would be absolute value. And I will mark you guys wrong for having incorrect looking parabolas. And I know the more narrow the graph is, the more V-like it might look. Just be careful, okay? I don't want any straight lines here. We're not graphing lines. These are parabolas. Now, on to B. We have some work that we do have to do here. That might be a little bit more than A, because I have this in the form ax squared plus bx plus c. And then let's remember that c gives us our y-intercept. So our y-intercept is 0, 2. So that's a point that you guys can plot pretty quick. Just make sure you remember that's not your vertex. We do have to find the vertex. So to find the vertex, x equals negative b over 2a. B is 4. You can come in. B is 4, so this is negative 4 over 2 times 1, which gives us negative 4 over 2, which is negative 2. Now that I have my x value for my vertex, I need to find y. So negative 2 squared plus 4 times negative 2 plus 2. So I'm taking my x value and I'm plugging it in so I can find my y. 4 minus 8 plus 2, negative 4 plus 2, negative 2. So my vertex is negative 2 for x, negative 2 for y. Hold on a second, guys. I need to pause it. All right, let's get this finished. That was like a 20-minute pause. I'm getting frustrated. Okay, so we found the vertex. We have found the y-intercept. So I can plot my vertex, which was -2, -2. My y-intercept was +2. And then we need to remember, through your vertex is your axis of symmetry. So I have my y-intercept on the right side. I can use the axis of symmetry. This is 2 away from your axis of symmetry, so go 2 away on the other side. So now I can see my parabola. I have the shape of the parabola. And sorry, that was the ugliest parabola I've probably ever drawn. Okay, so there's my parabola. If you have more questions on this one, you can ask in class when we're going over this. All right, let's get this last one finished and wrap up this video that's taken me like an hour. So this one, you're probably looking at it and you're like, oh my gosh, we have a fraction. It's just part of math, you guys. We have fractions that we have to deal with. So based on this fraction, I know that my parabola will be wide and it will open up because it's positive. My y-intercept is going to be 0, -1. So all I need to find now is my vertex. So x equals -b over 2a. So I have a, b, c. So -1 over 2 times 1/2. Now you're panicking about this being a fraction. This actually works out very nice. Your 2's cancel here. And we're left with -1 over 1, which is -1. So now we need to find y. So I'm going to plug in -1. So I have 1/2 times -1 squared plus -1 minus 1. So -1 squared is +1. So this is 1/2 times 1 minus 1 minus 1. This is 1/2 minus 2. So I'm not going to go through anything extravagant here to find the y-coordinate of the vertex. I have 50 cents. I owe somebody, or I buy something that's $2. How much more money do I have to find? So please don't overthink this. This is -1.5. So it's like 2 minus 1/2, 1.5. So my vertex is -1, -1.5. That's not difficult to work with. Go left, -1, go down, 1.5. There's my vertex. I'm going to go ahead and plot my y-intercept, which is 0, -1. I know that I probably did not make a mistake because my graph should be opening up. And if I graph my axis of symmetry through my vertex, I can find the y-intercept, which is 1 away from the axis of symmetry, so 1 on the other side. I see that this is going to be a wide parabola, and I see that it is opening up. So I probably did this correctly, and I'm just going to draw in my rough sketch of my parabola. And that's it. We have graphed our parabolas. We've used some information to make it easier for us to graph. In your next video, you're going to start getting into the features of these graphs and the max and the min. So that will be on the next one. But I really, really hope that this helps you guys be able to have a little bit more confidence in graphing quadratic functions, and that they really are probably not as bad as you remember them being from Math 2. Any questions? Make sure you ask tomorrow in class. Write down any ahas. And if you need to, go back and watch this again.